Okay, settle down, people. It's 10 o'clock.
So it's about time for us to get started. If we can work our way down to one BOF in the room at a time, it will probably be helpful to the area directors. I am Spencer Dawkins, and this is Ole Tron. We are your happy BOF co-chairs for the Loops BOF. If you're in the Loops BOF, you're in the right place, and if you're needing to be somewhere else, we'll miss you. This is a BOF at the IETF, so it is covered by the note well, which many of us have seen, and references BCPs, which all of us should have at least looked at once. This is our agenda for the day, and wanted to give a brief pause to do agenda bashing, if anybody has thoughts. So good, excellent. So we will go with this agenda. Please remember that this BOF is not working group forming, which means that we're thinking. I wanted to do a little scoping for our discussions. We're not replacing the internet, QUIC, or TCP. We are talking about optimizations where things work but don't always work well. We're talking about optimizations between network elements not involving hosts, and your network might not need loops, but somebody else's network might. I think the first law of optimization is first do no harm. And so that's one of the things I'd like for people to be watching for in our BOF. We're talking about a transport independent optimization. We are not changing the end-to-end transport protocol payload. And our goal for this BOF is that we agree on what happens next. So there's a lot of things we could talk about for 2 hours, but I would like to direct your attention to helping us find out what needs to happen next. Our face-to-face time is precious. This is not a work group forming BOF because, for among other reasons, the proponents were meeting for the last day and a half, and they were learning a lot from each other. What I think this means is that different people are working in the same space, but since there's no IETF activity yet, they're not doing things the same way, and there wouldn't be, anything they produce would not be providing the same services. So it sounds to me like kind of an opportunity for us to avoid our experience with NATS, where we said this is a bad idea, but people did it anyway, and they didn't do it here for the longest time. People come to many BOFs for many reasons. Note that it's possible to watch a train wreck while looking down at the train. We're not going to ask if you came to see a train wreck, but we are going to ask who consider yourself, and this is show of hands kind of thing, primarily a transport person? More than anything else. Okay. So about a third of the room, you think? Cool. Who considers yourself primarily an internet application person? Or internet encapsulation person? Okay. That's almost as many people as transport. So we have the right co-chair. Application layer is a smaller number, but thank you for being here. Primarily operations. We have two. Excellent. Cool. This is double the number of the average BOF at the IETF. Primarily a measurement person. That's okay. Cool. Yeah. So at least like 4 or 5 people in here with that expertise. Primarily a security person. We're seeing one hand, 2 hands, and I'm pretty sure that they're all at the quick thing at A&RW. That was a joke. Who's read the Problems Opportunities draft? Wow, this is, what would you say, a third of the room? Yeah. Cool. And who is working on a product that does local transport optimizations? I'm counting 8 hands-ish. More like 10. Yeah. Okay. So maybe this is not a proposal from one person or group.
Sorry, Aaron Falk, Makamai. Are you a product or a system? I mean, some people are not building products. I don't understand the intention of the question. So doesn't matter. So, oh, that I don't understand.
Yes. And thank you for clarifying questions. Hi, Corey.
Hi, Spencer. I'm taking notes. Do you want to say what you found out? Or do you just want to tell me afterwards?
I can send it to you afterwards, but to summarize, it's 1/3 transport, 1/3 internet, 1/10 on application, 2 people on operations, 5 people on measurement, 1.5 on security, perhaps. Oh no. A third of the room has read the Problems Opportunities draft, and we have sort of 10, 12 people who are actually working on products in this area or systems in this area.
Fabulous. Thank you. So I'd like to just put the questions to guide us between now and IETF 106 up. We're going to loop back to this slide at the end of our discussion time, but these are questions that I am going to be asking for hums and mic line. If you're humming, no, to help us understand why not. And so, like I say, you'll see the slide again, but I wanted you to have it in your minds as we started the discussion. So I think we're ready for Karsten. And and that should go back.
Good morning. Monday morning is not my time. I defended my PhD on a Monday morning, and I did survive that. So quick question. Who in this room was not in one of the previous loop side meetings we had at the last 2 IETFs? Okay, so it makes sense to say what I'm...
So about half the room for Corey.
Thank you. So basically, can you do the forwarding correctly, the slide switching? It's not doing full screen. You have to, yes, that button. Yes, thank you. Cool. Yeah. Okay, so basically, this is about packet loss. If your network doesn't have packet loss, you're probably in the wrong room. Well, more interestingly, if packet loss is not a problem for you, you're probably also in the wrong room, because all we are going to do for the rest of the morning is looking at optimizing things so we have less packet loss. And I probably should mention that one form of packet loss, for instance, is tail loss. Michael has provided this nice demonstration of tail loss. So there's always a little bit of latency consideration behind that. But what we are primarily trying to do here is reduce packet loss. And the approach is to do the simplest thing that could possibly work, which is we have a network path between two hosts that are oblivious to what's going on here. And we have two nodes in the network that cooperate. Both are on path, they cooperate in reducing the loss. And it's about compensating for losses that happen in the path between the two nodes. So I think it's hard to do something that's even simpler than that. So that is what we're trying to do here. And of course, there are things like retransmissions and FEC and things we could do or could not do. And that's possibly something that a working group could later find out what exactly we want to do. But right now, let's try to understand the problem. So the point is to recover packets locally. So locally has two meanings. It means close together, low latency, but it also means with no impact on the rest of the network. And that of course requires a little bit of thinking how you really can make sure that there is no impact on the rest of the network. But the main thing is doing it locally allows us to do it with low latency. That's one of the objectives. The second thing is we want to do it in the network. So host participation is not required. That doesn't mean that there shouldn't be activities with host participation. That's fine. But it's not what's on the agenda today. So we want to do this in the network. And third thing, because we don't want the host to participate, we don't want to touch the host's packets. Traditionally, PEPs have been very intrusive and have looked into packets and actually changed packets. And this is not the objective here. The objective is that the packet that comes out of loops is the same one that came in. It's just more likely to actually re-emerge than it would be without loops. And this, of course, means it works with any kind of IP packet. So encryption is not a problem for what we are trying to do. So don't look and don't touch. So with these three framing things, scoping things, it's pretty clear that any solution would have retransmission, forward error correction, or both. And right now we are looking at a solution that actually can do both. And of course, for retransmission, you need some information going from the egress to the ingress, which we call reverse information, like X, next, whatever. And you also typically include some forward information, although Michael will talk about a case where you actually don't need that. So if the terms reverse information and forward information come up, these are things that need to be done. And these are the things that actually we want to standardize here so we can interoperate. The same thing is true for forward error correction, since that may not be as familiar to people. It means adding redundancy to the packets. So if you lose one out of a group of packets, you can recover independent of which of the packets you lost. This has some latency advantages, and it gets really good when you do a dynamic selection and adaptation algorithm for the parameters of the FAC. Things like block size, if you have a block size, and FAC rate, how much redundancy do you actually add? It helps to dynamically adapt there, and to be able to adapt, you need measurement. And we will see a few other places where measurement is useful. And finally, it turns out there are some hybrid approaches where you react to a neck by adding FEC. So this is not out of scope. What we don't really want to spend a lot of time on is things like protocol setup, negotiation, and so on. We're assuming that this happens in an environment where we have some controller thing that does these things for us, and we are hand-waving there. This is not meant to be part of the effort, but of course we need to understand what information needs to be in that setup. So maybe in the end there will be a Yang model or something like that. Okay, the other part, as I said, we don't want to influence what's outside there, and the most important thing is we don't want to blow it up. And this means we have to be careful about concealing packet losses, because if you completely conceal all packet losses, then of course the end hosts will ramp up, and you get into all kinds of problems because you will increase congestion. So a necessary component here is congestion feedback to the end hosts. And yeah, the preferred way, of course, is ECN. We have a way to do congestion feedback. But for those flows that cannot use ECN, we also need a fallback so we don't get a deployment problem, deployment disincentive. Everybody is waiting for ECN. Actually, some informal measurements make me very optimistic about ECN, about the percentage of traffic that already is ECN capable, but that's maybe not for this BOF to discuss. And the other observation is we assume the transport protocols on the hosts will improve over time. And we want to play the puck a little bit to where they will be at, not where they are now. So we are assuming more ECN, we are assuming more time-dependent loss detection stuff like in REC, instead of packet number dependent loss detection, and so on. So there are a number of improvements that may shape the optimal solution of things for loops. But since we are not picking anything today, that's just something to keep in mind. Yeah, so in summary, we want to do the local recovery thing. We want to do some measurement, both to set recovery parameters, like when do I stop retransmitting? And also, if we have to signal congestion by actually dropping packets, we want to do this as little as possible, and maybe measurement can help us understand whether a loss was a congestion or a non-congestion loss. And we have to do the actual congestion feedback. What's not in scope, but what maybe at some point some people want to do, is adding multipath to the picture. Well, traditionally, I would propose adding multicast, mobility, and security. That's always the three things that make things interesting, but multipath has joined that list. Also, we are not really into diagnosing that path segment. We have ways of diagnosing paths, so IOM and so on. This is not really what we are trying to do. We are seeing the path segment as one thing. We want to do some measurements on it, but we don't necessarily want to understand which of the nodes which of the links is causing the losses. MTU handling is not something we will be the first to solve. I mean, it has been tried before, and we know that there are a number of solutions that are not always very satisfying, but we will just live in that space. Thank you. And finally, since this needs tunneling, we probably want to use some tunnel encapsulation. This is not about defining one, and not about choosing one, but really we want to be able to use any tunnel encapsulation that's out there. And there are some sketches to make sure that's possible, but these are proof of existence sketches and not things to choose from. There are a couple documents out there. For the problem opportunities draft Spencer asked about, there is a Strawman proposal we will spend a couple of minutes on later. There even is a charter proposal for a loops working group, but we are a non-working group forming BOF, so we are not going to discuss that. And there is a loops mailing list you may want to join, or you may want to consult the archive.
Well, thanks a lot, Carsten. Yisu, please. You have 10 minutes.
Can I ask a question?
Please. Yes, go ahead.
Marie-Josée Montpetit, I'm the co-chair of the Network Coding Research Group, where we have a tunnel where we do per segment coding, where we have dealt with the issue of hiding losses and not breaking the internet, where we do have error recovery. And I'm wondering why we need another group to do that.
So the one possibility would be standardizing it in the IETF.
Okay, yeah, we've been a research group, but yeah, because a lot of the problems that were stated here are things that we have been addressing for what, 5 years? Or something like that.
Yeah, this is why we have BOFs. This is good. Thank you.
A lot of people in this room have been working on this for 5 or 10 or 15 years.
Well, I've been spending ever since I graduated from college, and looking at my old age, you can imagine
Yes.
how long that was. But I would say that, yeah, there's already a lot of work been done in our research group that could actually profit this.
Absolutely.
you.
And then I have some slides about that later. But everybody in this room can go home comfortably thinking this new work is a spin-off of their work that they did before. So this will be an NWC RG spin-off if it becomes a working group, if that helps.
Hi, Bob Briscoe, independent. I just want an answer to this question. When you move from a per link retransmission to an overlay retransmission, you stop being able to tell whether it's a transmission loss or a congestion loss. When you're on a per link, you know whether it's a transmission loss or not. But once you go away from that, you don't. So the statements you made about wanting to avoid hiding congestion loss don't square with the scope of the BOF as far as I can see, because you're definitely on a multi-link scope.
So tying the recovery scheme to the link helps you, but I don't agree with the other half that if you are not tied to the link, you cannot say anything. I don't agree with that.
Well, how do you know the difference between congestion loss and transmission loss if you're not on the link?
Well, maybe the delay went up.
Maybe.
The delay went up.
Okay, so you're then starting to do
But that's
much
something
more clever things in the network,
that we will have to look at. And there is a number of things you can do relatively safely, and there are a number of things that maybe are a little bit aggressive. And there we are right there in congestion control land, where we have a number of algorithms and mechanisms to choose from. And there will be BCPs and everything. I think this needs to be examined. I just want to point out, we might want to do that.
I might come back to it. Okay.
If I could just say real quickly here, one of the questions that's on our list of questions is how much of this is what's research and what's engineering. So we are kind of headed towards that question in the first couple that have come up, and I wanted to thank you all for helping us to understand that one of the questions. So Ted and then David, or David and first? You all.
David Black, as Transfer Working Group chair, or one of the chairs, want to quick get up to quick plug some related work. First of all, Bob Briscoe, who just sat down, has written a couple of drafts that are mostly done in the working group, headed for IETF last call soon. Of important interest to this group is that they explain a bit about how to handle ECN at tunnel egress. In particular, Bob's just written some text on fragmentation that might also apply to FEC if you don't look at the details too closely. So I encourage looking at those drafts. One of them has ECN and CAP in the name. The other has RFC 6040 update shim in the name. We apologize for the not exactly intuitive draft names. And then, having mentioned tunnels, there's a long-suffering draft in Int area on tunnels. Please read that and don't reinvent it.
Thank you, David. Those are both TSPWG working group drafts, right?
The interior one isn't.
No,
but
there's three
first
drafts.
two,
There's two TSVWG drafts. One has ECN and CAP in the name. One has RFC 6040 update shim in the name.
Cool,
And
thank
then
you.
there's an Int area draft on tunnels. And of the three, the Int area draft is probably the most important because it reflects a bunch of things learned over a long time the hard way about tunnels.
Thank you.
Ted Lemon. So to me, so I'm a little frustrated by what Karsten just said, because to me the most interesting problem that needs to be solved in this space is the problem of the edge device, the leaf device, talking to the border router between a constrained network and a bigger network. And so if that problem is out of scope, then I actually have no interest in this work. That's not to say that I don't think it's a good idea. I personally don't have interest in it. So, and I'm not saying that you should change your mind. I'm just raising that point to point it out to you.
Thank you.
Stefan Weger. One thing that came to my mind is I think this problem that was described here is, at least for many more tricky links, solved in proprietary ways by basically everyone. And I think it's also quite common that say when you have a satellite link, that your satellite uplink and your satellite downlink and the boxes attached to it where something like this has to happen are from the same vendor, and they do their vendor specific thing. Why is that not sufficient anymore? Are we standardizing just for the sake of standardization? Good, thank you.
Next presentation. Take it away now.
Thank you. So I'm going to present a use case. So hopefully some of the questions can be answered when we have a very specific use case. So here is the usage scenario we are trying to introduce. Thinking about intercontinental WAN path, for example, from Paris to Beijing, either over MPLS or over internet, but here we're trying to focusing on over the public internet. So we find out as the default path does not always give the latency we required or the best latency. So what we are trying to do is look at the small square here. We create the workload from multiple clouds in different geographic sites to build a better WAN path via the overlay nodes, those square boxes, actually the overlay nodes. We call it cloud internet overlay network, SIAN or something. So we have put this virtual nodes or cloud routers globally. Then we have experiments based on 37 cloud routers. Then we find out with them, we have 71% chance of finding a better path in terms of latency. So what's next? We find out even we have a selected path gives a better latency, the loss still exists. Then there are some pretty well-known negative impacts of packet loss in long-haul network. The long-haul network here, we refers to the long pipeline, at least like tens of or hundreds of milliseconds. So there are tail loss problem for short flow, which possibly caused by the timeout, possibly a few seconds at the sender, or it may take an additional RTT for TCP retransmission. So the long flow completion time is expected in this case. And for large flows, the throughput is the large flow, they cares most. So there are chances that the TCP sender actually reduce its sending rate even when the loss is not caused by a persistent congestion. So in summary, the packet loss negative impact most because of the end-to-end transmission. It takes time, especially in long-haul network. So to have some further study on the packet loss pattern, we have this picture. Sorry, it's a little bit small, but for this, it's in Chinese, but you can guess. There are locations. I mean, there are Shanghai, Beijing, what else? I think there are Silicon Valley and like Sao Paulo or somewhere. So each pair of them, there's the small square here actually captures the loss rate. So it can be easily identified that the loss over past segments has very different characteristics. Some of them, the loss is persistently high, and some of them, the loss almost can be ignored. And some of them, the loss vary over time. For example, getting higher over the peak hours. Yeah, something like that. Then another finding is the loss over a single specific segment may affect the end-to-end loss significantly. That is to say, the loss detected by the end-to-end path actually can possibly be contributed by a short single segment. So in our usage scenario, there are at least two new opportunities we find out that can solve the packet loss problem. The first one is in this cloud internet, we have overlay nodes. They partition the whole hash into shorter segments naturally, and we can enable the per segment operation. For example, quicker recovery from loss comparing to end-to-end, and also we can do the adaptive recovery. So the adaptive here means for each of the segments, we can decide whether we should enable the local recovery or not, or we should use the retransmission, or we can enable the FEC with different level of redundancy. Another opportunity we find out is the overlay nodes nowadays have computing and memory resources, so are capable of providing the complex features like loss detection, recovery, measurement, ECM marking, all those things. So here, this page trying to show a little bit on how the segment-based measurement can help determine the cause of a packet loss. Look at the picture here. The left-hand side, actually, I think it's from where? Frankfurt to Shanghai? Oh no, the right-hand side from Frankfurt to Shanghai, and the left side is from Shanghai to US West. So the blue is the loss rate, the red is the RTT. So we can see there is a strong correlation in these two cases. So that somehow implies if it has such a pattern, the high correlation pattern, then there is a loss. Then we check at that time, the delay is high, then it's highly possible that loss is caused by a congestion. Otherwise, it's possible that caused by a non-congestive reason. So why we care about this? Remember the slides that are shown by Carsten? Somehow we want to feedback the congestion information to the sender. So that's how the segment-based information help us. I believe in the solution sketch presentation may touch more on this. So to summarize, I have introduced this a particular scenario, and the overlay nodes allow us to improve the packet loss over some specific tunnel-based path segments, and we are requiring mechanism to be defined to achieve the local recovery, and at the same time minimizing the undesired side effects. I kind of think the loops binds to existing overlay tunnel encapsulation. We do not want to invent a new encapsulation. That's all for this.
Okay, Gori.
Gori Fairhurst. Can I try a question? So we have these effects going on at multiple layers. So when I put my operator hat on, I'm doing stuff at layer 2, maybe layer 3. then I'm doing routing control to try and eliminate these things. And I've got transport protocols running over the top. I see real dangers that we have too many layers trying to cross-optimize the same things over slightly different timescales. Is this something that you're considering?
Okay, for this one, I kind of, it highly depends on the deployment, because for this one, we are thinking there are some underlay nodes and it's not under control of the operator who provides all the small square boxes. So this is an overlay nodes managed by somebody else. So that's why we have layering, so naturally.
But do these people providing the underlays not also wish to optimize their stuff? Are they not doing traffic engineering? Are they not looking at the BGP tables and considering how to optimize this?
That's all. I'm trying to say, actually, there are some underlying optimization that's the, I mean, operators are trying, I use, right?
Mm-hmm.
Yeah, I think it's possible, but that part is not the, I mean, the provider with this layer will be worried about. And from some of the experiments we show, actually, the latency, I mean, we call it the underlay, actually. The underlay latency given by them is not satisfied. So that's why the middle layer operator want to do something by themselves.
Aaron Falk, Akamai. Thank you, Li Zhao, for your presentation. It was very clear. I thought it was very helpful. Could you go to the slide that shows the delay and loss rate? And I think this is the point that Gori was making, which is at every layer that you are implementing loss recovery, you are converting loss into delay, because each layer is doing some sort of loss detection and then recovery to ensure successful transmission. So that's happening at the link layer. That could be happening between routers. You're doing it between your cloud routers. So what that's going to do is that's going to mask some of the signal. So if you are using an indication of delay to say, correlated with loss, to say that this is congestion-related loss, you may be incorrect in that, because what's happening is that a layer underneath you is converting that loss that it's detected into delay.
So what we are trying to do is, at least we need to do no harm. So this is just an example to show, in case there is a strong correlation, what possibly we can do. But if people really have worries about this, we can just do the local recovery and then let the sender do as they usually do. I mean, if they want to decrease the sending rate, just as a conventional TCP sender. But at least we are doing no harm. That's, yeah.
Okay, thanks.
Tom Herbert, can you go back to the slide with the graph, and that shows the topology?
Which one? Sorry.
The topology graph.
The topology?
So this kind of makes it look like the majority of the transmit path is the long haul, which in regards to the latency, seems like that would be where the most delay is. So if local recovery is over the largest part of the path, I'm not sure that that's going to be very different than end-to-end recovery. So that's, can you comment on that?
Yeah, that's fair. I think that's a fair comment. So from our experiments, we normally we have at least 3 segments. I mean, so as the previous presentation Carsten have showed, if there is a longer segment that is RTT is almost equivalent to the end-to-end, then I don't think we should enable loops.
So I imagine, so you break it into smaller segments to get the advantages of localization. But then the obvious problem becomes, well, if I have loss at each segment, I now have additive delay, which is making the problem even worse. So just some of the things, I'm sure you're thinking about these things.
Yeah, so that's why, I mean, during the solution considerations, I think we want to make the recovery mechanism more adaptive. So sometimes for certain segments, maybe we don't want to enable it at all. For some of them, maybe retransmission okay, and for some of them, FEC with different redundancy might be applicable. So that's, yeah, but we don't have a very specific solution right now, but because there's a non-working group forming both. So that's what I'm thinking.
Spencer?
Spencer Dawkins, speaking as individual contributor. So one of the things I wanted to be sure and say was, and I'm glad that Aaron stood up and started talking. Aaron and I co-chaired the PILC working group, which produced the advice for subnetwork protocol designers a long time ago. And one of the things that's in there is about being aware of retransmissions. We did that so long ago that people were still running IP over X25. And people were still saying that they wanted cellular hops that were completely reliable. So those kinds of things. So we've had, the IETF has done work that required, that tried to help people be aware of that problem. And I think what we're saying now is that problem is at more than one layer down. It's more than one layer, more than two layers that could be arguing. And so I think that being aware of that is going to be really important. And this is kind of what I was thinking about when I was talking about performance implications of path characteristics at the RFC talk. Thank you.
You want to say something?
Andrew McGregor.
Is this a new point, or are you in the same thread?
It's in the same thread. It's returning to the previous point about doing no harm with the correlation between
name, please.
delay and... Sorry?
Name, please.
Andrew McGregor. If you hide or smear out in time the correlation between congestive loss and the delay, you're doing harm. End of story. Because it reduces the ability of the congestion control to see what's going on. If, on the other hand, you have some level of non-congestive loss, then papering over that is purely a good thing. The question is, can you tell the difference? And that's the key problem in all of this.
Yeah.
And so the reason it works at layer 2, by the way, and there's probably more than 4 instances of an algorithm that does exactly this per person in this room running, is that that it's not congestive loss, right? Wi-Fi, you have an error rate that's rather high for an internet link. You dropped a packet because of that. Well, fine, just paper over it, right? Whereas, if you don't know on a long haul path whether it was congestive or not, you should probably leave it in the stream.
So let me answer that quickly. The point of the congestion feedback is to not lose the information. Now, let me answer the other question, which is essentially, we have survived the last 30 years. Why are we doing this now? And there are a number of things coming together. And the cloudy stuff that Lijo talked about is maybe one aspect of it. But I think the important observation is this is not supposed to replace the existing internet. This is a particular performance optimization that you can employ at specific places in the network that have the characteristics to make this useful. And having a sizable part of non-congestive loss probably is a precondition to make this really worthwhile. So there is an assumption, there is a controller somewhere that is looking at the network and already has some measurement data, and that helps you decide where to put a loop segment and where not to put one. And the third observation is the loop segments work best when they are short. So this is not supposed to be an edge-to-edge thing. This is supposed to be in the network, deeply in the network. And the final observation, when you think about this problem, try to strike from your minds that a retransmission scheme has to do resequencing. So most people who want to do something in this space don't want to do resequencing. Many link layer solutions today have to do resequencing because the link layers are defined to be sequence preserving. And also the tunnel-based solutions often do resequencing. And this is pretty much about exploring the space where you can have performance improvements without resequencing.
Okay, thank you. So John and Young Long, you're next. So that's one more presentation on use cases for this problem, and then we're going to talk a little bit about solution sketches. Just in a matter of timekeeping, we're running a little late, but I think this discussion is very useful and important to understand the problem. But at some point, we're going to, draw a hard line and ensure that we get both questions answered as well.
So you're enforcing MTU size on time slots. Good job.
The problem is that the questions that have come up make me think I need more than 5 minutes. So anyway, so I'm going to show you a couple pictures about satellite use case. So basically, today it's TCP. We put a PEP in there over satellite to optimize. One of the things it optimizes is recovery from loss over the satellite link. A particular thing that makes it a little different than what was talked about earlier is there's still going to be latency there, even with a loops-based solution. But the key thing we're looking at, though, is with the move towards things like QUIC, we can't do split TCP anymore. So we need some kind of underlay. As was pointed out, we actually have proprietary solutions now. So one of the questions that come, well, why are we looking at potentially a standardized one? Well, one is maybe we could leverage open source solutions, especially with respect to solutions that include more advanced FEC. The other thing is, for my future thing, which is out of scope, I think Ted brought it up, even though right now we're not looking at going to the end host, you need this part in the middle to get there. Because I would like to optimize recovery over that Wi-Fi link at my remote site also. So, in the longer term, I want to build on this solution to get to the point where I can actually recover, because that's another thing that PEP does for me, is it gives me the local recovery at each of the 3 split spaces. So that's kind of where we're looking at it, in terms of why we're interested in this from the satellite point of view. So I kept it under the 5 because I talk fast. Are there any questions?
Fantastic, you recovered 2 minutes. Oh no.
No, actually, I'm going to create
hi.
I'm sorry, I'm going to create a problem here. Actually, again, with the network coding research group chair, we're actually having 2 drafts that actually want to put FEC inside QUIC to deal with losses without adding another layer. So how do you how are you going to deal with essentially 2 layers of FEC, one below, which is what you want to do in loops, and the one that we already have inside QUIC? Why do we need 2 loops?
Well, I'm actually very interested in that solution also, because it can learn something about the network and be very specific to the transport protocol. This is more generic. But also, hopefully I would set this up to be intelligent enough that I wouldn't use this one if I didn't need it, if it was there, or maybe I use this one, QUIC's still going to have a learning curve to figure out that I'm on the satellite link. So I think they can play together, but there's 2 different approaches, and I'm actually interested in both solutions towards this. The FEC inside QUIC is very interesting to me.
Okay, because, I think what I hear here is that there seems to be a gathering of a ton of different pieces of information that come from a ton of different groups and research groups. And I don't know if one task that you guys want to take is actually to see what exists and what has been done and what can actually be used here. Next slide set. Okay, well, thank you. But what I'm saying is that, yes, there is going to be FEC inside QUIC, and I hope that we do not work against one another.
Yeah, I guess one of the problems I have with the way you just said that, you said there's going to be, it's research. Is it really going to happen?
Okay, I have to say that the reason that our draft is not in the QUIC working group is because they are focusing on delivering the first version of the product.
Yeah.
And we didn't want to come into QUIC and with this FEC proposal and mess things up.
Right.
It will, and actually, I will tell you that the way the draft is being structured right now, it is not structured as a research draft. It is structured as a working group draft, but we're holding on to it so that Lars can start sleeping at night and not figuring out that we have these people coming with yet another add-on to Quick that will prevent me from taking the last 2 hours of sleep I had it. So yes, it's inside the research group right now, but it is not to be a research paper. The strategy is the minute that these guys issue version 1 or whatever the stable version they have, we are coming in the working group. Thank you.
Okay. Yeah, and I hope that's the way it works out. I was trying to hedge my bets.
Yeah, Carsten, I just wanted to say again, we want to play the puck to where the end-to-end protocols will be. So of course, yes, we are considering FEC that is being done end-to-end. So that's useful stuff going on. And what Loops can do is provide FEC in places, in specific places in the network where it's needed and not having the overhead in other places. So this is 100% complementary. And yes, the fun part will be getting the two dynamic adaptation algorithms work together correctly. That will be enjoyable, and I'm looking forward to it. Well, I don't have the research for that yet. But again, there's a difference between a protocol and a mechanism, and we can standardize things at different times. So when we understand good mechanisms to do this optimally, we should standardize those, and we should define a protocol within which we can do these mechanisms investigations.
I should probably mention that we're kind of getting towards the discussions that we would have at chartering time for a working group, which is not, that's not the conversation we're having here. But that is stuff that we have to think about, and probably stuff that has to appear in the charter, but it's just not necessary for us to know what to do next after noon today.
Lars Egger chairing the Quick working group. So we don't have FEC on the agenda at the moment, on the charter at the moment. And while there's significant interest in having some sort of FEC in Quick at the moment, they're all individual proposals, right? And there's no working group consensus on what to do with this. I will point out that FEC was actually part of Google Quick at some point. And it was removed, at least one particular way of doing FEC in Quick, because it didn't deliver on the promise. A new proposal for doing FEC in Quick might be different, right, and better, and might us to cause it to put back at the moment. There's no such plan on the charter. Thank you. And I have this visual image of needing to, like, the hordes are piling against the castle gate, and as soon as V1 drops, we're going to be. So I know I'm going to sleep now, but.
Hi, Aaron Falk. So I think that. I came here to try to get a better understanding of what the problem is that the people who have use cases feel that they need to solve. I think that will inform some IETF activity. Maybe it happens in a new working group. Maybe it happens in an existing working group. And also to learn about some existing proposed solutions to try to understand what the solution space is. What's changed and what are people doing. So I think that the network coding is an important piece of that. The Quick is a piece of that. The overlay stuff is a piece of that. So I don't see, this is an informational BOF. So we're not making decisions about what's going to happen. We're trying to understand the problem space. And so I don't think we need to have the argument about where the work is going to happen. We get to do that in a working group forming BOF.
Yep. Oh, thank you. Yeah, thank you. So Jianglong, you're next. You.
Morning, everyone. This is John Long from China Telecom, and I like to present a petition scenario that loops could be applicable. As it mentioned in the draft, I will talk about SRv6-based enterprise WAN connection use case for loops. Firstly, I will take a brief introduction about the background. ChinaNet is the largest public internet backbone network in China. It mainly provides broadband internet and e-cloud access both for public users and enterprise users. The entire network devices are IPv6 enabled, and we plan to support SRv6 segment routing over IPv6 to provide the path selection to meet service SLA. However, when we deploy some services over the internet, for example, enterprise usually require network connection between the branch offices or between branch offices and the cloud data center over geographic distances. The problem we encounter is that the traffic over the internet is subject to lose due to the best effort networks. So there is an urgent need to do network optimization to provide high quality internet for specific service that needed the reliability of data transfer. The following is the use case. As the picture shows, there are two branches of the enterprise which access the internet through VCPE for one connection. And VCPE connects to a cloud-based POP, which further directs the traffic to VPC for cloud access. You know, VCPE is an NFV virtual node in the network, so it can be enabled with some vinyl-added services to be provided from providers' work. So we can see there are three typical services deployed. The yellow one, the yellow line represents the WAN connection, and the green line represents the cloud access, and the red line represents the DC interconnection. So obviously, we can see one VCPE to another VCPE. VCPE to a cloud-based POP. POP to POP can be over a long distance, which could be divided into multiple subpaths based on SRv6 segments, but some of which must have packet loss generally. So this is there will be a opportunity for loops which can be enabled for the segments of this subpaths to solve packet loss and provide the data for path selection. With this deployment, we can provide high quality internet connection in terms of loss rate. So, do you think it is an applicable use case for loops that we also should focus on? And I think it can be applied to the enterprise WAN connection scenario. Apart from that, SRv6 provide the path selection naturally, so it could be a specific encapsulation protocol for loops. So it could be considered in the following work. So if you are also interested in this topic, welcome more comment and discussion. Thank you.
Okay, thank you very much. So the next presentation is by Michael, giving us some ideas of what solutions could look like. The Spencer says definitely start a timer, so you take that as a hint.
Yeah, I'll do my best to be a little bit over time here. All right, quick overview of how loops could work. I got the impression from the discussion already that some people tend to have a specific image in their mind of how a loop system is going to work, like it's definitely going to do FEC, or it's definitely going to do resequencing. And I think none of these things are decided yet. So this is just an overview of the possibilities that we have. You know, some things that we thought about, a strawman of the information that would have to go between an ingress and an egress so that this whole thing could operate. That's the context for the following details. You know, we have data going into an ingress. We have data that's possibly encapsulated, not necessarily. There are two possibilities here that I'm going to explain. Towards an egress, the egress is going to ACK or NACK or both. and then the ingress is gonna retransmit, or it's gonna use FEC, or both, right? Well, probably not, but retransmit or use FEC, and then, well, the end goal is that much better data leaves the egress, right? I mean, more data, less loss. That's the goal here. So the problems that we'll have to try to address are loss detection and retransmission. We need to somehow do something about loss. We need to, well, probably work on FEC. Then there will also be a need to detect congestion that happens on the path segment. There will need to be some measurement, there will need to be some congestion detection, and we'll need to think about how congestion is signaled towards the end host if it was detected. Can be done by dropping a packet, which is against the whole purpose of loops, but you could drop, a better packet than the last packet. Could be done using ECN, which is preferable. Some concrete ideas on how these things cooperate are coming now, but it's just a straw man. There are two modes here that I'm going to present to you. The first is tunnel mode, which is, I guess, closer to what most of the things are that you've seen so far. Step one of the steps that you've seen is encapsulation. You would, on the ingress side, encapsulate it in something. We don't specify how yet. The document has sketches of GUI and of Geneve and how it could be possibly done. But the point is you would encapsulate and add some information that is necessary, such that we can reflect, for instance, sequence numbers. We can use, proper X. So you need, obviously, right, you need to identify packets, you need a sequence number. We identified also some other information, tunnel type and ACK desirable flag. I'll get to what that is about quickly. Next slide. And whatever may be needed by FEC. So regarding this ACK desirable flag, there are two blocks that are currently being envisioned for the feedback. These blocks would be just sent in some way, right? They could be interspersed, they could be repeated, they could be piggybacked on packets. But the point is that there are two information blocks that are transmitted from the receiving, from the egress back to the ingress. One is an optional, so both are optional. They don't always have to be included in every ACK. One would contain the PSN, the sequence number, and an absolute reception time, such that we get the delay signal that could then be used as a congestion indicator. And the other one would contain an ACK bitmap. That's based on the packet sequence number and the delta indicating the end of the last PSN of the bitmap. So that's the feedback. And then getting the feedback, the ingress will do something, right? It gets NACs, or it learns about missing sequence numbers from this ACK bitmap, or it would get an RTO, make a decision that's somehow related to the congestion estimate that it's taking, possibly use ECN, if that works, to somehow influence the decision, calculate the latency variation from the timestamps in feedback blocks. And and then it would either retransmit or send FEC repair packets, depending on how the design goes. The egress on forwarding, it would, if FEC is used, it would defec. It would have to inform endhosts about congestion if needed. So there is an opportunity here to make it, to distinguish between congestion and corruption loss, or some other form of loss, loss that happens that isn't congestion, if we can do that. Something that I find personally interesting about this, as people were saying, this would introduce delay, and it would, if you can't, in the worst case, you'll have to inform the end systems about loss here. I see that as an opportunity to make use of ECN signaling. You have end systems today that use ECN, and basically no equipment inside the network that makes use of ECN. So here there would be some equipment that could, basically you could turn a loss notification into an ECN notification with this, right? If you have ECN capable senders, you can tell them. So that's a summary slide of the information exchanged in tunnel mode. On forwarding, the packet sequence number, tunnel type, ACK desirable flag that would inform you that occasionally you want to have this timestamp included. anything that's needed per FAQ. And for backward, these two blocks, one that contains the timestamp, the other one that has this ACK bitmap. Now, just to show that this whole thing could be done in a much less intrusive way as well, and a very different way, we get to this transparent mode that's in the appendix. That's a bit more radical, and the point here is to have the least intrusive possible thing. The goal is to never delay anything and to not even tunnel. I'm just discussing retransmission. You could do the same with FAQ. You could have all kinds of variations in between the spectrum here. But in the simplest case, you would on the ingress side just forward and keep a copy of the packets with the hash of a packet so you could identify it. So it's just taking a copy but forwarding, not adding any header or anything. The hash calculation may need to include data beyond IP, but this is not relying on a specific protocol or anything. It's just taking the bytes. And the egress would answer. In this idea here, it would ACK. It couldn't NACK, right? Because we don't have consecutively growing sequence numbers. We just have hashes. And the ACK format could be similar to the tunnel mode. Now, the ingress, upon seeing that there's an RTO for one of the hashes that it has, it could make a decision to retransmit packets. That should be done based on a congestion estimate as before. The cost of a hash collision in this whole thing is kind of low, because what that would mean is you miss a retransmit opportunity. If you have a hash collision, you just can't store it in your cache, so you reduce the probability of being able to retransmit something. And the egress would just forward. So that's in that particular case, that's all it would be doing. There wouldn't be any reordering. I think sending things on without resequencing, I mean, yes, you have modern TCPs that can handle that well. You have REC, you have spurious loss detection mechanisms, but I think it's important to keep in mind that for TCPs that don't have that, or any mechanisms that don't have that, the worst thing that would happen is that you don't have the benefit of the retransmission, right? It's not going to be any worse if you just forward. You just don't have any benefit in the worst case. Then there will be UDP-based transports or all kinds of transports that might, not have a big problem with the reordering anyway. So there may not always be a need to delay packets by resequencing. To summarize this, on forwarding, you wouldn't add anything extra. On backward, you would have roughly the same thing as before, these blocks 1 and 2. They would have to look slightly different. Block 1 would be limited in some way because this ACK desirable flag doesn't exist. We don't have any forward information, right? Yeah, and then everything is about hashes. So Black 2 can't really have this ACK bitmap. We could maybe you have a Bloom filter or something like that, some interesting way of encoding ACKs. And that's that. So the point is, there's a spectrum of possibilities here. We're not trying to nail it down to one specific mechanism just yet. Rather, the idea could be that we could have a framework that would allow to implement several mechanisms. In all cases, it could be pretty beneficial when the RTT on the segment is much shorter than the end-to-end RTT. That's already, well, I think these things have been said. Wireless NICs use that fact. And, well, I believe in the benefit of reducing tail loss. Yeah. Clarifying question. I don't think we have, we're getting close to the slot of the longer discussions anyway, so.
Yeah. Thank you, Michael.
All right. Then, yeah, this FAQ is next.
And excellent work on time management. Thank you.
Okay, so whatever. So there are a number of questions that come up again and again. Some of them already have come up. Just to answer a few of them. So one misunderstanding we got early in the process was that this was only for encrypted traffic. Well, it's for any traffic. And the message is that we can work with encrypted traffic. and loops does not peak beyond layer 3. Well, maybe the port numbers, but not beyond that. So that doesn't mean that an implementer couldn't apply some secret sauce they still have from the PEP days and do wonderful things by peeking forward and combine them with loops. But we're not going to standardize those. So the solution we are discussing here is based on don't look, don't touch. How do we actually know which of the packets in an aggregate are worth recovering? And the answer is loops doesn't have a way to find out, but there is a little bit of an assumption that the setup mechanism, the controller-based setup mechanism that you use for installing a loops pair somewhere in the network might also have a way for the ingress node to sort between the usefully recoverable ones and the ones where you wouldn't care. Gori.
How would it have an insight into which ones were better to recover?
Well, it might be port number 80. I don't know. There may be ways in your network, you know, oh, this is an important customer, so we're going to support their application, and this other customer hasn't paid their dues, so we are not supporting their application.
Okay, so it sounds like div-serve call point or something, which probably exists.
Completely out of scope for this. Third question, how do we transport the measurement-related information, or actually any reverse information? Any measurement-related information that is going in the forward direction probably would be put into the encapsulation as a form of an extension together with a sequence number. So if you needed sender timestamp for some reason, we would put it there. We're not currently advocating for that. And the reverse direction could be done the same way we do the ACK information. So again, that depends a bit on the encapsulation. If you have a bidirectional tunnel, you might be able to piggyback it. If your tunnel is unidirectional, you have to send separate packets for the X anyway, and you can include measurement information there. Can you do the full screen thing again? Full screen, full screen, full screen.
Karsten?
Yes.
David Black, real quick note on your second FAQ, which says this is an L3 only mechanism. I assume that's intended to scope for whatever comes out of here. Is that correct?
Yes.
Okay. I want to quick point out, and I apologize for not doing this during that second presentation. In the satellite presentation, if you look at what a satellite PEP does, it does two things. One is it does some things here to deal with losses as soon as you can figure out that something has not bounced off the satellite. The other thing that it does is it mucks with the transport protocol to grow the window. Historically, this was needed because endpoints just didn't have enough buffers to fill the pipe up to a satellite and back. The former would be within scope for loops. The latter would be out. You'd have to do it in the transport protocol itself somehow.
Thank you.
Okay, the third question that comes up. Loops has some cost. Even transparent mode has some cost because you have to send forward and back the ancillary information. How do you know that this cost is actually worth it? And again, we assume we have some network intelligence, some controller thing that understands what's going on in the network. We may want to put something in loops that might actually enable the protocol to dynamically be switched on and switched off to make this quicker. But the assumption is something is providing the information and providing the monitoring that allows making that call. Yeah, and I think the final question has been answered, but just to repeat, we need congestion relay. We don't want to lose information in that tunnel So we need to do dropping for non-ECN capable transports. And yeah, we can do this by dropping. We can probably more usefully do this by simply not doing retransmissions when we know those would be dropped for congestion feedback anyway. Okay, so let's talk about related work for a moment. Gori has a better idea. I'm looking forward to him telling me after the meeting. So, of course, as we said, many of us have worked on systems that did something like that. Some people have sent mail about interesting papers about this. We know that link layers are doing that for us all the time. And if we look closely at these link layers, these are often tunnels in reality. Yes, this is being done, and an important part of the actual work will be to get a better overview of what's going on there. Lars.
Hey, Carsten, Lars again. So I'll note that there's a lot of related work, as you say, in the IETF, but the most sort of common thing that was brought up today are PEPs. And those we don't have in the IETF because the vendors of those boxes have had no interest in an IETF standard, ever, right? Has that changed? So will those vendors participate here, or are we standardizing something that then will never get actually shipped?
Well, I can't talk about PEP vendors.
Is the interest from the vendors that traditionally, so this is very close to a PEP box, but we don't standardize those here, we never have. Not for lack of trying, simply because the vendors weren't interested. Has that changed? Are the vendors that traditionally have shipped these boxes to customers, do they want common standards in this space now?
I think that's very much a business decision for them.
Well, have they decided that it's in their interest to have a common standard?
So do you think that's a prerequisite for doing this work?
Yes.
I don't think so.
Because otherwise it's going to be useless.
No.
If I could do a chair interrupt for just a second, well, I think one of the things that is relevant here is that that's a really good question for working group charter time. But I don't know if we're going to be able to figure out the answer between now and 12 o'clock that would guide us on what we do after 12 o'clock. So I would encourage everybody to not have a food fight about business models and things like that, but it is an important question for us to talk about at charter time.
I mean, my answer would be that time is playing for more and more software-based networks where a much larger variety of vendors are coming into play. So the opportunities, I think, are something that we can try to leap onto right now. I don't think that traditional hardware vendors might be the first ones to pick up after the experience that was correctly recited, but that's not the market anymore alone today.
Nice. Hi, Aaron Falk. I want to respond to Lars's point. I think that what we've heard here is expression today of operators who see this as a problem that they want to have solved. The fact that a set of vendors doesn't want to solve their problem for them is irrelevant, right? They want somebody to step forward and solve it. They're asking the IETF to do it. If the IETF doesn't do it, then they'll find some other solution. That's what happened. That's what the PEP vendors did.
So the economist's word is, this is disruptive. We don't need the old vendors.
Nicolas Kuhn from CNES. That might be more a charter level discussion or question, I don't know. We speak about PEPs, but this discussion is also relevant for all the software-defined WAN equipments that are in the market today that are not interoperable. So if we want to standardize something, we may want them to work together, but there are already lots of solutions that do these kind of things. And also something that I think is missing is the discussions now needs to distinguish whether the scope is enterprise networks or public access, because as soon as we have public access, we have all these layer 2 mechanisms that will break whatever. We're just adding another layer on all the existing layers.
Thank you.
I just want to give a very specific example following Tola's comments regarding why we want to standardize this. For example, currently we have an NMV function, we have VCP and a V gateway. So they're possibly provided by different parties. So that's why we want to standardize it.
Hi, Stuart Card, Critical Technologies. I just have a couple of points on scoping. There's a focus on loss mitigation, and there's an assumption that we can really only help when the round trip time on the path segment is significantly shorter than the end-to-end round trip time. Neither of those need be the case. If you think of path segments as essentially being transfer functions, and different path segments having different statistical characteristics, they are different transfer functions. And so the end-to-end transport protocol is presented with a composition of functions that it may not be able to handle. And so the different transport protocols with which we are familiar make certain assumptions about those statistical distributions and congestion versus non-congestion losses and so on. It may be that by simply taking a segment that exhibits a different statistical distribution than the end-to-end transport protocols are anticipating, and causing that segment to conform more to the expected distribution, we may enhance end-to-end performance even if the segment that we are mitigating has a long round trip time, and even if the underlying problem is something other than loss.
Yeah, I think that's particularly true if the other segments contribute something to how the composition feels in the end. If the other segments are completely lossless, completely clear, you're not winning a lot with loops.
Tom Herbert. So thinking about the use cases, this actually looks a lot more like a piece of QoS to me. So we're basically offering it does in the sense we're offering a path with more reliability or lower latency or something like that. So if you view it as that, it sounds to me like this could be considered one type of QoS for a path, and then something like the PAN-RG or some of the other efforts to make QoS aware networking might be applicable. So the application or the transport layer may in fact know about this information. It could then adjust its transport layer. I know you want to keep it transparent to the end host, but there actually could be advantages if you could somehow expose this to them.
Yeah, there could be advantages to path-aware networking. We are not solving this problem in this room. But I have a slide on that.
One comment, I know you want to keep this completely independent and all at layer 3, but the second you have any sort of multipath where you have, you can take possibly 2 segments, you're going to have to make sure that you do that per flow at the transport layer. So it's inevitable you're going to have to look beyond layer 3 or use the flow label or an IPv6 or something like that.
Brian, do you want to come up again when I talk about pathway networking, or do you want to do it now?
Oh, no, hi, Brian Trammell, wearing my PAN-RG co-chair hat. So I just heard PAN-RG said like 3 times, so I was summoned. I would say that the problems that we're trying to solve here in loops are actually kind of overlap with a lot of the problems that we're trying to solve in PAN-RG. The approaches that we're looking at in PAN-RG are entirely different. In that PAN-RG, we're looking at taking the this information, whatever measurement information you get from the path that goes into the loop's ingress point, we're actually taking it and taking it all the way to the endpoint, right? Like, so we have a completely different aim. We want to modify the endpoint so that it can do path-aware sort of stuff. That being said, there's a big question going on in PAN-RG as to what is an endpoint. Is a tunnel ingress point also an endpoint? Maybe, I don't know. So one of the outcomes of this, like, so things that are a little bit less engineering and a little bit more researchy could certainly come over to PAN-RG and be digested a little while and then come back into the IETF. I think that's a good way to do it.
So Aaron Falk again. We shouldn't lose the sort of initial insight from your opening slides, which is that the concept here is to fix packet loss close to where it happens, which is not what end-to-end FEC or PAN-RG stuff is trying to do. Now, there are other benefits, but that's part of the trade-off space, right? That if you have a good put increase if you are able to do that. So I just think we shouldn't lose track of that.
Thank you. Okay, now to my presentation. Haven't really started yet. I wanted to quickly point to 4 pieces of work inside the IETF, and actually in one case inside the IRTF, that are interesting in this context. One, of course, there's lots of work on measurements, and we want to stand on the shoulders of those people and not on their feet. There is actually some work already on a loops-like recovery thing going on, which you haven't noticed yet, because it's happening at the internet layer. There is the network coding research group work and the TSV working group work, in particular on sliding window FEC. I'm singling this out because it seems to be the next thing we want to touch, but there are, of course, other things we want to look at there. And there is something called tunnel congestion feedback. So let's talk about these 4 things quickly. IOM, or in situ OEM, is used to collect information within the packet while the packet traverses a path between 2 points in the network. So it's about hop per hop information. It might return the measurement to a third party using postcards. My observation would be loops is really about an ingress and an egress pair and not about lots of hops. So at some point we may want to mix the two in some form. So loops may be able to make use of information that IOM provides. But right now this seems to be a little bit different. IOM also uses the generic information model approach, which is not new in the IPPM community. So we can certainly learn something from there. So we can map our protocol to multiple formats. And speaking about formats, the data formats that the IPPM people have developed and maybe some measurement methods are, of course, things that may be applicable. So that's related work number 1. Related work number 2, the 6LoWPAN fragment recovery work, came up in 2008 in the 6LoWPAN working group while I was still chairing it. I have spent the last 10 years mainly in trying it not to make sure it doesn't happen. But at some point, the 6LoWPAN group was dissolved and replaced by the 6LoW working group and so on. And this is now done. It has passed working group last call in the 6LoW working group and will hit the ISG soon. Now this is a little bit different because it's about fragments within a packet. It's not about packets. And a number of parameters constrain the situation a lot, so that actually may be more tractable than it would have been in the global internet. And of course, again, the congestion control issue is the interesting one, and the question about the control loops working against each other. So this is work that's going on, and I would expect other pieces of work will be going on in the IETF at some point when it's really needed. So I think it would be good to bring these things together in loops. I mean, I don't mean stopping this work, but just learning from it and going forward. The sliding window FEC, I think, is interesting, which has left the network coding research group and is now in TSV WG drafts, and that's certainly something that will go into a good loops solution. And finally, there is the tunnel congestion feedback framework. Well, yeah, this is one more of those TSWG drafts. Dave Black mentioned a few more ones that we may want to use. There is an IPFix mapping in there. We may want to use that as a source of information elements that need to be part of loops. Okay, I'm doing this really quickly. I just want to say what is really out of scope of loops. And really the litmus test here is, do you need host participation to make this happen? And well, Panergy is about host participation. Aaron?
Sorry, I just want to challenge your framing of this question, because it seems to me that, you know, we're motivating this by several operators who say they have a problem. You know, I think it'd be, they haven't said that host participation is impossible from their point of view, that it's a requirement that the host cannot participate. And I'd be interested in knowing whether that's actually the case or not.
Yeah, maybe I should have been more specific, because in the slide that John showed, you have this loops thing in one of the end hosts. But the interesting thing about this loops thing is, in an actual implementation, this would be in the VPN layer. It would not influence the transport layer in the host.
I'm sorry, you're talking about the solution, not the problem. I'm trying to understand the problem, right?
Yes.
I don't care whether loops is the solution yet until I understand what the problem is that it's trying to solve.
If I could just do a interrupt here, it would have been reasonable for us to say at the beginning of Carson's presentation that this is Carson's view, and that these are the things that we could talk about at charter, you know, and probably really at charter time. So it's not necessary for us to figure out what all the linkages are, really, but to figure out where we need to be with, you know, with observations like Aaron's. So thank you. Yeah, thank you that. Thank you.
So it's not on the slide, but did I hear you? It's out of scope?
From my point of view, yes.
Yeah, but I mean, why?
Because we want to solve a tractable problem first before we do the intractable ones.
And how do you make the judgment call about what's tractable and what not?
At charter time.
Yes.
No, I'd say, I mean, there is no reason to try to constrain, you know, the specification of the solution to something that you must not deploy however you figure out also on the end host, right? Why not?
No, the point is that this thing works best if there is not a deployability block that is caused by hosts. This is really what I'm trying to say.
Nobody said you must deploy it on the host. The way I perceived what you were saying is that you exclude the, you know, option to even do it on the host.
Well, the host is a node, and
right.
it's actually in the network.
I think the question has been noted, and and the community needs to be aware of that question as we discuss things further.
Yeah, so I think this really helped clarifying the concern here. So the point is, if we do this right, it doesn't require host people to do something. Now, there is one other thing, for instance, the spin bit discussion in Quick. If that creates something that could be used, that's great.
If the problem that you're trying to solve with loops is on the last or first hop to the host, how do you solve it?
Well, maybe solving it second. The difference between the in-network case and the case where the host is involved is that with a host, a number of additional considerations come in. Like, how do you actually do the setup? What are the privacy considerations? And so on.
No, you just brought the example, right? If you basically simply do it, sure, implementation questions aside, just, you know, as part of the network layer in the host stack, then you're having exactly the same architectural model. You're just also able to include the first last hops in the solution. So I don't think we should go beyond that, but that option certainly shouldn't be excluded.
So I think we are actually moving past the end of Carson's last slide and into technical discussion. So I'd like to thank you, Carson, for leading this section of the, or for sharing the maps and gaps analysis that you've done so far. Very helpful. And I think we are to open mic time We have a timer running for just a little under 17 minutes for us to talk. And then we have 10 minutes, a buzzer will go off and we'll have like 10 minutes to talk about hums and things like that. So please make your comments, please make them succinct.
Brandon Williams, Akamai. Just one quick thing about the previous talk. For completeness, the network coding research group is also looking specifically at satellite use cases. It would be valuable for you to track that as well.
Thank you.
Hi, Bob Briscoe again. I just want to, I said I might come back to this, and I'm coming back to it because I've not heard an answer to the question. I don't get why you want to do something on an overlay that's relatively easy on a link, and the link, if the link knows it's bad, it will do it because they want to sell their technology. So why try and fix something that someone else has got the motivation to fix anyway, and they can do it really easily, and it's really difficult to do just slightly above that layer? It just doesn't make sense to me.
Thank you.
Gus Bowman. So that's actually interesting because in a rational world, you would be right.
But there's a but coming, isn't there?
So the person who wants the optimization may not be the person that owns the link.
Yeah.
That's the answer to the question.
Are you talking equipment build person or operator person?
Yes, both.
But what I was saying is that those that develop technology have and standardize it, the IEEE or whatever link technology, they have a perfectly good motivation to do link layer retransmission if it's going to make their link better.
So that's actually not the case. So, yeah.
Okay.
So,
Aaron, could you dive to the mic?
So I'm no longer a satellite person, so John can stand up and correct me. But just to use a satellite link as an example, but any physical layer, right? When you design the data transmission for the link, you basically make an effort. I'm going to try so hard to get the data through. And then at some point I'm going to give up. And there's sort of an economics there of like, how much data can I consistently get through under what conditions? You make an assumption on how that link is going to be used, right? The person who designs and runs the link often knows very little about the application, and the application owners or the various parties that are in between the end application user and the link designer may have very different ideas of how that link is going to be used. And if the link is better than they need, nobody complains except maybe about price. If the link is worse than they need, then some other party has to try to improve the data throughput, right? And that's what we're talking about now, right? The assumption here is that the link is not good enough, right? Otherwise, you don't deploy this at all. If the link is good enough, then we don't have this conversation.
Yeah, and the other case that Ijo talked about is where the person who wants to make the optimization sees a path. The person doesn't have access to all the individual links. It only has the path, and they want to optimize the usage of their path. But I actually wanted to give another example where what you said is not working. Ethernet is standardized by IEEE, and wireless Wi-Fi is kind of trying to be like Ethernet. And there is one constraint in Ethernet that IP doesn't have, which is Ethernet is sequence preserving. IP is not sequence preserving. So we can do things at layer 3 that you cannot do at layer 2, which is weird, but it's the current situation.
Yeah, I was just thinking through what Aaron had said, and I was thinking that the big change that you're proposing needs to be split into two parts: the overlay part and the sequence not preserving part. And once the link people know they don't have to keep the sequence preserved, then they've got a different way of fixing their links. You know, currently they do it to a certain level and then they think, I can't wait any longer to get this retransmission because I've got to keep everything in order. I'm buffering up at receiver. But if they can relax that constraint, then we don't. Yeah, yeah. Well, the paper I sent on the loops list a couple of days ago says how you can now know whether rack's being used or not, and so you know, or something like something that's less order concerning. Okay.
So Gary Fairhurst, we said, was it a transport thing? If you start fiddling with ordering and changing the transport properties of your path, then this is certainly a transport topic.
Tom Herbert. So to me, it seems like the biggest value use case of something like loops would be long path delay, say over the internet, where one of the segments within that is low delay, but possibly high loss. And to me, it sounds like that would be a mobile network. Satellite's interesting, but that seems like that already has a long delay. So I'm wondering, or guess asking, are there applications in mobile world where we do have that situation, like at the last hop or radio network getting to that point? That could be the low delay, high loss. Is there value for loops in that scenario? Or is everything already covered by some layer 2 retransmissions that's not an issue?
Spencer Dawkins speaking as an individual contributor. I like Tom's question, and I would offer as a semi-friendly amendment, what if there are two network segments like that? And that you know, it seems to me that we can't really guarantee that there would only be one. And so to the extent that there is more than one, I think that changes the way we look at the problem.
Well, look at it this way. What's the most common use case? So we have our mobile phone connecting to a wireless network. Eventually it gets into the internet and goes to Google or whatever. So I'm assuming that that later part is already pretty highly reliable, but the longer latency. But I'm really interested in it is that short path where we could definitely have high loss. And to me, if Loops is optimizing that, and it seems like the key here is if we're going to do these retransmissions, it has to be so fast that that really doesn't affect the end-to-end view of delay. So if you can just slip this in and save a packet loss as opposed to increasing delay, then there's a value.
Yeah. I would also maybe observe that when Aaron and I were co-chairing PILC, the common case of what people were optimizing for was like 56 kilobit links. So, you know, think we should probably think towards the future as well.
Stuttgart Critical Technologies, just a specific example of such a low latency, high loss case. IEEE 802.11p, wireless access in vehicular environments, dedicated short range communications, especially when you're handing off from one access point to another.
Thomas Eckert. I missed the beginning, so I'm not quite sure if the scope was more about, you know, dealing with congestion loss or non-congestion loss, right? What I would say is that traditionally, you know, the non-congestion loss is something that, you know, subnets try to get rid of. But, you know, if we look through the industry, that hasn't always been very successful. So I think one of the questions would really be, you know, how are we weighting the scope of, you know, congestion loss, local solving, and non-congestion loss, local solving, right? And I think it would really be nice to have something that's more generically applicable to all type of subnets if you have a sucking subnet where it doesn't, you know, the provided mechanisms of that layer 2 subnet are not good enough to deal with the loss it has, the non-congestion loss.
We've cleared the mic line, which I find amazing. We have about 17 minutes until we're through. So it may be time for us to loop back to the questions to guide us.
Right, so the biggest one, do we understand the problem? And I don't know, Spencer, do you think we should have a discussion on each of these, or should we try to do hums as we go?
We have 17 minutes, but we've only got, 16 minutes, but we've only got 16 minutes. Let's do hums and see if we need to do a discussion on the no, that's wrong.
Are we already? No, we didn't. Okay, prepare. So those who think that we do understand the problem, can you please hum now? Thank you. And those who do not think we understand the problem, please hum now. Okay.
50-50.
Yeah, 60-40 perhaps, but yes.
So we made the right choice by having a non-work group forming buff.
Hi, Aaron Falk again. Let me try to articulate what I think I heard, because this was exactly my mind in thinking about this question, which is we have identified a bunch of problems. I don't think we've identified how they group together to become the problem. There's work that's going on. There's a lot of history here. There's stuff that is kind of outside the scope of the IETF, and it's that there's mechanisms that are happening way down in the stack and in the applications. I have not come away from this discussion with a clear idea of the thing that's unaddressed that there needs to be work on. So that's what I heard.
I was trying some 70% pulse modulation. I understand the problem. So I think it very much depends on a lot of the scope details, right? So I haven't heard, just vague substantiation of trying to differentiate between different traffic, right? Obviously, congestion control expectations of DC-TCP are different from TCP, right? Would we be willing to do that? Then the whole discussion of why the heck would we want to exclude the last thing. So understanding comes a little bit through the refinement of the scope. And I hope that we can solve this for me 30% remaining.
Hi, Brian Trammell, no hats at this point. So I hummed yes, because actually I think we've understood this problem for the past quarter century. And we've had the problem for the past quarter century, and we've come up with a bunch of bad solutions for it, right? So the thing that I'd like to see a refinement of is, one, a little bit of the refinement of the scope, but two, a little bit more of the not the scope of the problem, but also the scope of the solution, right? Like, so a little bit more discussion about which exact subset of the we do not have complete clairvoyance for every pass segment of transport problem do we want to solve here? And then a little bit more of the reducing down the solution space to something tractable. I think this BOF was a very good sort of start to that, and I'd like to see it continue. But yeah, that's why I hummed yes and still came up with the mic line.
And thank you to the presenters and everyone who participated for that.
Yeah, given that half of us don't understand the problem, yes, should we see what no, go on, Spencer.
So one way for us to rephrase the question now is that I think I heard assertions from multiple people out of the research community that at least some parts of this are engineering. So as long as some parts of this are engineering.
Go back to the previous thing, because there were some comments on the microphone that made an important distinction between the problem and the scope of the problem. I think 60% of the room answered the question, do we understand the problem? And 40% answered, I don't understand the scope of the problem. And can we...
So if I was going to do a friendly amendment to the question that's on the screen, I think I would be suggesting something like, is there engineering, are people ready, are there things that we've talked about today that we're ready to do engineering that don't need additional research? And I was thinking before the BOF that if we had enough people show up saying, I'm working on this now, that was, at least some people thought that. But the microphone lines are open, as they say.
Yeah, Jörg Ott quickly. Looking at the first bullet, I was actually humming with the question in mind whether we have a common understanding of the problem, right? So everybody may have their own idea of what the problem might be, but it might turn out to be useful to have a common one. And I haven't really, that hasn't come across to me.
Hi, Colin Perkins with no hats. Is this engineering or is it research? I would say that big chunks of this are engineering and parts of it are probably still research, but I think that's okay.
This could be a good topic at the IRSG dinner.
I mean, to expand a bit, I think there's enough of this which is engineering that there is a useful IETF work we can do. There are bits I think we don't necessarily know how to solve. I think we don't necessarily need to know how to solve them all to do an initial version of this. It wouldn't be the first time the IETF has chartered a group where we don't have all of the answers at the beginning.
So, Stefan Wenger, I come back to that question which I had originally. I read here, is this engineering or is research required, blah, blah, blah. I would say absolutely there is research required, maybe not technical research, but I think there is insufficient input on whether there is actually a demand for such a standard, for a standardized solution. That I do not see personally.
David Black, I hummed no on not understanding the problem because based on the previous comment I heard, sort of matches mine, which is a bit concerned about the scope. Is there a problem here? Yeah, there's probably more than one. I've heard the discussion wander back and forth across levels 2, 3, and 4. And I think I want to see a clear focus on one of the levels with a clearly defined scope to change my hum from no to yes.
Thank you, David.
Aaron Falk again. So I think what I heard very clearly was a proposed set of requirements for a protocol. Something that operates over a subset of the path, doesn't involve the endpoints, works on IP, is transport independent, and doesn't modify packets as they go. What I'm not clear on is how important is that? How useful is it? What set of problems it solves? Having said that, I'm not opposed to seeing somebody go and build something like that and try it out. I don't know if I would recommend that it be used on the internet or what problems it's going to be useful for. But so to me, this is, even with that statement, it's not obvious to me. It's in the gray area between the IRTF work and IETF work. I wouldn't actually be opposed to it in either place. I'd kind of like to see the thinking of how this could work move forward. I would also like to see it not interfere with some of the other ideas for improving things like FEC and Quick and the PAN-RG stuff. So I'd say if people want to work on this, they should be able to work on it. I wouldn't stand in the way. I don't think it's necessarily a bad thing. Just don't think we should overpromise what it's going to do.
Wes Herdeker, ISI. I guess with my IAB hat half kiltered, because I have questions. I'm not a statement or a. So the whole point of the IRTF, and I'm very glad that there's people here that are working on that part of the IRTF. It's not me. The whole point of the IRTF is to eventually transition work into the IETF for standardization, and I think that this whole BOF shows that there is now an effort or a desire to transition to something that might actually work. I do think that the proponents and the research side need to get together, and it seems like there's sort of a split between of groups, and they really need to sit in a room and say, okay, what elements are ready for transition and what is still in research? And if solutions exist, great, now is the time to push those forward into standards so they can actually be deployed and put into interoperability. The one concern I have is whether the research community in particular agrees that there aren't issues that are hiding, where even though the engineering side may say, we think we have a solution, the research side say, no, we haven't actually figured out like the whole, how does congestion get in the way, and how are we going to make sure that we're not actually adding, that the engineering solution doesn't add to the problem. So just my thoughts.
Yeah, so I think, the list of places that we need to look at for this work, in addition to just what we're thinking about here, I think that's going to be not a short list. Thank you.
Andrew McGregor, I think the answers to the first two questions very strongly depend on what the scope turns out to be. Because there are things in here where I'm certain there is research required in the potential scope of this, and there are other things which are like, yeah, sure, we can do that. That's fine. So yeah, it really does require a very careful discussion on scope.
So Carson has been standing there for a long time. Do you want to go now or wait for?
I'm hearing a lot of people who think research is required on some of the questions that came up today. I'm still not really hearing that people think that there is research required on the things that we're trying to do.
Sorry. Yeah,
Local control loop, response reply,
Yeah, control loops. Yeah, I'm still not very sure about how all this interacts between different layers. So there's transport questions and there's ops questions, and I guess there's routing questions here. And I'd like to see which ones of those actually have concerns and by whom, because the use cases we saw were simple, but are people signed up against those two use cases, or do they have more? And so I see questions here. And I think these are research questions, so we don't see data now with the answers.
So let me clarify this. What we need to do is standardize a protocol. What we also need to do is understand how to correctly use that protocol, all the mechanisms. So TCP was standardized in 1983 or something, and or 76, depending on how you look at it. And we are starting to understand the mechanisms now. I think we can go ahead and do a mechanism, do protocol work, excuse me, on loops now, and fully understanding that we will have 5 years or so looking at all the research questions that finally go into the BCPs on how to best run your congestion control mechanisms and so on. I continue to believe that a basic version of loops can be built today. I mean, people here in this room have built it. So there are some existence proofs. And I didn't understand that the purpose of this BOF was to find out whether there's commercial interest, or we would have done more work in that space.
Yeah.
Yes, there's lots of interesting research waiting for us that is going to go into BCPs at some point. But the protocol stuff should be possible to build a first version of that.
So if I could do an AD interrupt, everybody stay at the microphones that still at the microphones. Magnus asked if we could do a hum, if people believe that standardization in this space is required, or if it's not. And if you think that it's not, if you hum that it's not, feel free to hop up to the mic lines. We've got about a minute and a half to go, but we'd be interested in hearing. Could I ask for a hum of people who think that standardization in this space is required?
Can we clarify the question? Yeah.
Is standardization in this space required?
Required is a strange way of phrasing it.
No, wait a second. You don't get to change the question. The chair has asked the question. Yeah.
I would be happy to ask that question as a friendly amendment.
Would
it be beneficial? Would standardization be beneficial?
Desirable or beneficial, I think, would be a more useful question.
Yeah.
So, right. So those who think that standardization in this space is beneficial or desirable, can you please hum now? And those who do not think it's desirable or needed, please hum now. Okay.
We are at 25 seconds left to go in our time as I'm doing it.
So let me bring up an important point, right? So nobody talked about, I think, analyzing what's already out there in the market. There are a lot of proprietary solutions to do these things. Yeah. They may cover a lot of IPR, but they may also set a good amount of references of, what we could achieve and, showing what we want to achieve compared to that stuff. So it's ugly work to try to do that analysis, but I think it would be very helpful.
Thank you. And that's actually, it's actually where we hand the mic to the AD.
So on this last thing, who's actually willing to do active work of looking at what's doing and working on this scoping? Can we have some hands? Okay, we have some 15 hands. That's good, great. So my conclusions here is that the scoping, etc., needs more discussion. We have the loops mailing list to do things. So please, if you're not already subscribed, go there and let's have some discussions about scope, etc., and what's available or not and what's been done. Okay. Thank you, everyone.
Thank you. Thank you all, and see you on the mailing list. Yes. You have no idea how much help I was.